Okay, in today's video, I'm gonna go through recursion. Recursion is basically when a function calls upon itself, and then it works towards a base case to basically retrieve a value. So let's say that we wanted to make a program that calculates factorial. Okay, so basically factorial of a number n. I would, of course, as always, set up just this end of file scan as we usually do. So let's say that this needs to be 1. Then we printf of, and we print the number n. Or no, we actually print the function. So print factorial of n. And we end that. And now we just need to make our actual function here. So let's say int factorial n. Then let's define it here in the bottom. So let's start with our actual. Let's start with this. We're gonna have a base case here. Then we're gonna have the recursive step in our else function. I'm actually gonna do the recursive step first because I'll tell you why when we do our second example. So our recursive step here is basically gonna be that we return n times and then our recursive step. So that's calling back to our function, but we change the value here. So we basically work towards the base case. Okay. Here we return n and we go towards factorial n minus 1. But this is of course gonna go on forever, right? Because let's say we added 3 here. It's gonna say 3 times n minus 1, which is 2, times 1, and then times 0, and then so on, right? It will go on forever. So we need to add something that stops here at 1 so we can get the correct value, because otherwise everything will be 0. So that's where our base case comes in. We basically add when n is 1, we return 1. Okay, so this base case is basically gonna return the 1, but it's gonna return the 1 to the function in the end, right? And then our function is gonna return to this. So it basically goes into itself. So let's say that we added 3. It's gonna do 3, and then it's gonna go into the function again, 2. And then it's gonna take 2. 2 is not 1. So we do 2 times factorial n minus 1, which is 1. And then here it's gonna return 1. So that's gonna become the 1, and then it's gonna go back and calculate. And if we were to run this program, let's say that we type 2, should be 2, right? 3, 6, 4 should be 24. So it works. Now let's do another example. Let's say we wanted to do Fibonacci instead. So the Fibonacci sequence is basically 0, 1, or 0, 1, 2, 3, 5, 8, and so on. You can skip the 0, and sometimes it looks like this as well. It's basically the same sequence, just defined differently. So we're gonna change all of these names, and let's do just like we did before. Let's add the base case, but let's not type it out. And let's do our else. Let's do this. Okay, so if we look at the Fibonacci sequence, we have 0, 1, 2, 3, 5, 8. Let's say the 5 here. The 5 is basically defined as 2 plus 3, right? So let's say that our n is 5. Then this 5 is basically defined as the Fibonacci of n minus 2 plus the Fibonacci of n minus 1. So this would be our recursive. We would return our function n minus 1 plus our function again, but n minus 2 this time. Right, so that is the recursive step. But now we have a problem. You see, we move 2 steps each time. So we're gonna need to return 1 when n is equal to 1, right? Return 1. But then this actually moves 2 steps, so we're actually gonna skip it, right? So it's gonna go towards infinity. If I were to run this program now, say I type 3, it's gonna go basically towards infinity. So we need another else if n equals 2, and then we return 2. Now if I were to run this program, let's see, so the first number should be 1, second number should be 2, and then 3, 5, 8. But although now if we type, let's say 0, it's not defined, right? So we could actually change this to the n 0, and 1 returns 1, and now it should work for 0 as well, right? And it should be the same sequence, right? The true Fibonacci sequence. But we have another problem here. If I run the program and I type, let's say I type something big, 45, this is gonna take a while to compute, okay? And that's basically because for each iteration, we basically split the calculation to 2 functions, right? So it's basically like a tree, right? Let's say that we start on 1 computation here, just 1 function. It turns into 2, and those 2 turns into 4, and those 4 turn into 8, and then 16, and 32, and then it keeps going. So for big numbers, this is actually not ideal, because let's say I were to type 50 here, it's gonna take a while to compute. So this function could be written a lot shorter by doing something like this. For this, we're actually gonna need to define the base cases. So we actually define them in variables, okay? So we first let's name this first, so it's clear. So this int first is basically let's say that it's our base case, because that's what makes sense. And then we declare a second variable and say that that's equal to 1, and then let's just declare a buffer. Okay, so that should be one of those. So this is basically like our base cases. And now instead of having recursion, we just return our first number here. So we return first. Then if I were to write, I basically write the computations myself. So let's say that buffer is equal to first plus second. That's the definition, right? So it's one number and second becomes the next. We could also name this next, because that might be a little bit more clear. So that's basically the next number in the sequence. So that's equal to first and second. And now we just take first, and we say that that's equal to second, right? Because we want to move everything 1 step. That's equal to second. And then we take second and say that that's equal to next. And now, of course, we need to work towards this base case, because otherwise, if we type, let's say 5, nothing will happen, because we need to remove from n. So we remove 1 from n. This can, of course, be written as that as well, or that as well. All of them are the same, but I like to write like that. Let's do this. And now let's try again. So let's type 0, should return 0, 1, return 1, 2, 1, and then 3, 2, nice, 4, 3, perfect, 5, 8, 13. So that's a way to write it a lot more efficient on the computational level. And if I were to write, let's say 50 now, it should be, that's probably too big for my computer to handle, and that's why it's that's why it's coming out negative. Yes, integers are, oh, that's for another day. Well, yeah, so that's basically recursion, or an introduction to recursion. It's a very, very powerful tool in loads of different computer or programming languages. So I recommend that you at least understand it or try to understand it, because it's very useful in certain situations. So yeah, thank you.